Section 3.4, Parallel Lines and the Triangle Angle Sum Theorem. Let's start out by classifying triangles by sides. We've seen this in previous classes, but this is just a review. Here I have a scalene triangle. That means I have no sides congruent. Next, I have an isosceles triangle. In an isosceles triangle, we have two sides that are congruent. And finally, equilateral triangle. In this triangle, all sides are congruent. We can also classify triangles by angles. Our first triangle is an acute triangle. All angles in this triangle must be acute, must be less than 90 degrees. Our next one, obtuse triangle. This has one obtuse angle. The other two angles must be acute. Our third one, a right triangle, has one right angle. Here we have one right angle. Our other two angles must be acute. And finally, an equiangular triangle. All angles of the triangle are congruent. Now that we have classified triangles by sides and angles, that gives us the triangle angle sum theorem. The sum of the interior angles of a triangle is equal to 180 degrees, whether it is an acute triangle, an obtuse triangle, a right triangle, or an equilateral triangle. Here in the diagram, I have triangle ABC. I know from the theorem that the measure of angle A plus the measure of angle B plus the measure of angle C must equal 180 degrees. Let's take a look at a proof of that theorem. So I want to prove that the measure of angle B plus the measure of angle C plus the measure of angle 2 in our diagram equals 180 degrees. My given information is that I have triangle ABC. I have that in my diagram. And that Q is parallel to segment BC. So I can denote that in my diagram. That is my given information. Now we have step 2. Angle 1 is congruent to angle B. I know angle 1 is congruent to angle B because if I have two parallel lines cut by transversal, then alternate interior angles are congruent. So this is by the AIA theorem. I'm also given that angle 3 is congruent to angle C. Again, I know that's true because if two parallel lines are cut by transversal, then alternate interior angles are congruent. So in the same step, I have the AIA theorem. Step 3, the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180 degrees. This is the angle addition postulate. The sum of these three angles is forming a straight line. Therefore, we know that their sum has to be 180 degrees. Now, I have step 4, the measure of angle B plus the measure of angle C plus the measure of angle 2. I know that the measure of angle 1 is equal to B, so all we do is substitute. The measure of angle 3 is equal to the measure of angle C. So again, we just substitute. And we have the measure of angle 2 already in our problem from step 3. So from step 3 to step 4, all we had to do was use the property of substitution. On the previous slides, we discussed the interior angles of a polygon, specifically a triangle. Here, we want to talk about the exterior angle of a polygon. That is an angle formed by a side of the polygon and an extension of an adjacent side. So we have two polygons here, one 3-sided triangle, one 5-sided pentagon, and we have identified the sides. We know here we have 1, 2, 3 sides. Here we have 1, 2, 3, 4, 5 sides. If we extend one side, that forms an angle with another side of the triangle, which it gives us the exterior angle of this triangle. There are multiple exterior angles in each polygon. For example, I can extend this side, and that would generate another angle. Again, I could extend this side, and it generates another exterior angle, or we could have two angles at a vertice. So we do have multiple exterior angles in polygons. Specifically, what we want to do is to talk about one angle per vertex, or one exterior angle per vertex, such as this. And it doesn't matter which side you extend. So you can see everything aligns evenly. I have 5 sides, I have 5 interior angles, and specifically, we can generate more than 5 exterior angles, but in our discussion, we're going to talk at 1 exterior angle per vertice. So here I have 5 exterior angles. Our next slide defines remote interior angles. This is the 2 angles that are non-adjacent to the exterior angle. So here I have a triangle. I have my 3 sides of the triangle. I extended one side. That generated an exterior angle at this vertice. The adjacent angle, we know, is the one that is supplementary to that angle. The remote interior angles are the ones that are non-adjacent to it. So here, angle 1 is my exterior angle. The 2 remote interior angles are angle 2 and 3. Those last 2 slides lead us to the triangle exterior angle theorem. The measure of each exterior angle of a triangle equals the sum of the measures of its 2 remote interior angles. So here, I have a triangle with an exterior angle 1. Its remote interior angles, the non-adjacent angles to it, are 2 and 3. And this theorem says that the measure of angle 1 equals the measure of angle 2 plus the measure of angle 3. A quick proof to this problem is if I labeled this angle 4, I now have the measure of angle 4 plus the measure of angle 1 equal to 180. Definition of supplementary angles, or by the angle addition postulate. And from the triangle angle sum theorem, I know that the measure of angle 2, 3, and 4 must add up to 180. These are both equal to 180, so I can just substitute. The measure of angle 4 plus the measure of angle 1 equals the measure of angle 2 plus the measure of angle 3 plus the measure of angle 4. Now you can see if I just subtract out the measure of angle 4 on both sides, I'm left with the measure of angle 1 equals the measure of angle 2 plus the measure of angle 3. Let's look at some examples. Here they want me to find the value of x in these triangles. I know from a previous slide the triangle angle sum theorem states that these 3 angles in this triangle must add up to 180 degrees. So I just take x plus 22 plus 104 equals 180. Simplify, x plus 126 equals 180. And when I subtract 126, I get x equal to 54 degrees. On my next slide, I have 2 angles in my triangle that are equal, but still I know the 3 angles must add up to 180. So x plus 18 equals 180. Simplifying, 2x plus 18 equals 180. Subtract 18 on both sides. 2x equals 162. Divide by 2, x will equal 81. Again, I have a triangle. Here I have an equal angular triangle. I know that because my 3 angles are x, x, and x. They're all equal. But I know still the sum of those 3 angles must add up to 180 degrees. Therefore, x plus x plus x, simplifying, gives me 3x equal to 180. Divide by 3, x is 60 degrees. Here I have a right triangle because I have 1 right angle in a triangle. These 2 angles must be acute. But still, the 3 angles must add up to 180 degrees. X plus 34 plus 90 equals 180. X, when I simplify, plus 124 equals 180. Subtract 124 on both sides, I get 56 degrees. On this example, they want me to find the value of each variable. In this diagram, there are multiple ways to find the solution for x, y, and z. As long as I apply the theorems correctly, it doesn't matter what direction you go to find those values. Here, I'm going to identify this triangle and use its exterior angle. And I know the exterior angle is equal to the sum of the remote interior angles. So I can set up the equation x plus 83, which are the remote interior angles, equals the exterior angle, which is 102. Now, all I need to do is to subtract 83 on both sides. And when I do, x is going to equal 19 degrees. Now I have these 2 angles are supplementary. They're a linear pair. So I can set up the equation y plus 102 equals 180 degrees. And when I subtract 102, y is going to equal 78 degrees. Now I can apply the triangle sum theorem inside of this triangle. I already know two values. All I need to do is find a third. So I can have z plus 10 plus 102 equals 180 degrees. Z, when I simplify, plus 112 equals 180 degrees. And z is going to equal 68 degrees. On my next diagram, all I need to do is use the triangle sum theorem to find the value of y. And I know y and x are congruent because they are vertical angles. So y plus 70 plus 50 equals 180 degrees. Simplifying, y plus 120 equals 180 degrees. Subtract 120 on both sides, and y is equal to 60 degrees. Since these two are vertical angles, x is also 60 degrees. Again, they want me to find the value of the variable in the diagrams. Here I'm given an exterior angle. I know the exterior angle is equal to the sum of the remote interior angles. Setting that equation up, I have x equal to 33 plus 42, and x is equal to 75. I also could have used the triangle sum theorem and found the measure of this angle. Then I could use the definition of a linear pair or supplementary angles to find the value of x. Still, I could have got 75 degrees. On the next diagram, I'm given an exterior angle and the sum of its remote interior angles. Therefore, by the exterior angle theorem, I can set the exterior angle, which is 4x plus 15, equal to the sum of the remote interior angles, 2x minus 10 plus 108. 4x plus 15 equals, when I simplify the right side, 2x plus 98. Subtract 2x on both sides, I get 2x plus 15 equals 98. Subtract 15 on both sides, I get 2x equal to 83, and divide by 2, I get x equal to 41.5.